Welcome all, welcome back at C-Square. In this lesson we'll talk about similar polygon and similar solid, and we're gonna find out some important relationship between perimeters, areas, and surface area and volumes of similar shape. First of all, let's see what the scale factor is, and here depends how you see it. If you go from the small to the large figure, and that's the thing I'll do here, the scale factor will be the ratio of the corresponding sides. So in this case, a prime b prime over ab, that will be one way to get the scale factor. Of course, you can pick any other two corresponding sides and you get the same thing. Very similar for the quadrilateral. You can write the ratio of two corresponding sides, and that is the scale factor. But in this lesson, like I said, I want to explore some relationship of some important feature of two-dimensional shape, perimeters, right? And if you notice here, these two shapes here are squares. Let me mention that all squares are similar. How do we know these are squares? Because we notice all the sides are congruent and we have a right angle. And the first thing I want to do here is to look to the perimeter of this small square ABCD. If you notice, the perimeter will be 4 times 2, which is 8. For the large one, will be what? 6, 4 times 6, let's be consistent, which is 24. What is the ratio of the large over small? I think it's better to look this way. It's going to be 24 over 8, which is nothing else than 3 over 1, or just 3. Now, please take a look here and you notice it's the same scale factor, because if I do 6 divided by 2, I get 3. This is the scale factor. So the ratio of the perimeter is the same with the scale factor. What about the area? Well, let's take a look to the area. The area of the small square will be 2 times 2, or 2 square, and that will be 4. The area of the large square will be 6 times 6, or 6 square, and that is 36. What is the ratio of these two areas? So again, I go large over small. I think it's easier to see it. And we have here 36 over 4, which can be simplified as 9 over 1, or just 9. And if you notice, this 9 is nothing else than 3 square. Okay, so this is a way to see what you're gonna see in a moment. Okay, a rule that will allow us to solve more math problem, obviously. And you see here I did the same math like in the couple minutes ago. Okay, so this is the rule that I like to mention, r squared, which says the perimeter have the same relationship as the scale factor r. On the other hand, the area have that r squared as a ratio. So, and that is the theorem, the rules summarized. Now, sometimes you can go, like in this case, you see small, large. That's okay also. So this is the same, and for the area, we need to square it. So let's see this example here. We have to find this perimeter of this shape, and we know of the large shape, and we know the perimeter of the small shape and the area of the small shape. So the first thing you want to do is to write the ratio of the corresponding parts. And I will honestly start with large, 8 over small, 5. I think it makes more sense. What is this 8 over 5? This is the scale factor for the sides of these two quadrilateral. But because you want to find the perimeter first, the perimeter of the large over the perimeter of the small quadrilateral will be what? Will be the same. r. So it's going to be 8 over 5. And if you notice, we know this perimeter, which is the small one, right? So I'm going to have perimeter of the large, the one we need to find out, over 20 equals 8 over 5. I'm going to do cross multiplication here, and I have 5 times P sub L, perimeter of the large shape, equals 20 times 8. Divide by 5 to get rid of this 5. And what do we get here? We can do this one like this. 5 goes in 24 times. 4 times 8 is 32. Okay, so the perimeter of the large one is 32. You may want to look to these numbers and see if it makes sense, if the answer is reasonable. It is reasonable, we should get a larger number. And also you can do 32 over 20 and see if you get 8 over 5. Let's go to the second part where we are asked the area. Now, whenever you want to find the areas, you need to be aware that you have to square r. So we have r squared here, which is going to be 8 over 5 square, which is 64 over 25. So now the ratio of these two areas, and again you notice I start with large, I think it makes more sense, would be 64 over 25. And now we know this area, which is the small shape. Okay, so we have A sub L, the area of the large figure, over 30 is 64 over 25. So we're going to do the same math like in the previous part. We're going to cross multiply, and we have 25 times the area of the large shape equals 30 times 64. We're going to divide by 25. On both sides, obviously. And I'm gonna grab a calculator to do that math. 30 times 64 divide by 25, and that is 76.8. Again, you may want to look and see if the answer is reasonable. I think it is. We should get a number larger than 30. And of course, you can do 76.8 divided by 30 and see if you get the same number like 64 divided by 25. On this second example, we have also similar quadrilateral. We need to find a scale factor of the quadrilateral ABCD to quadrilateral MNPQ and the length of AB. If you notice now, we know they are similar, very important, and we have these two areas of the small and the large. So again, I like to start with area of the large over area of the small quadrilateral. And in this case we have what? 400 square centimeter over 50 square centimeter. Now the units cancel out, we don't really need them, and 400 divided by 50, that will be just 8. So that is what? That is r square. Very important. This is r square, the ratio of the areas. So for finding r, we need to take square root. And that will be square root of 8. We just need a positive one, which can be simplified like as 2 square root of 2. Or if you need to evaluate, just grab the calculator. This is the ratio of the sides, the scale factor, and now we can, so we find the scale factor, we can move to the second part and find the length of AB. Now remember, we start with large over small, so now I'm going to start with large over small, and I'm going to call this x, you notice. So on my second part, I'm going to say 6 over x equals what? Equals that r, 2 square root of 2, and I'm going to multiply by x to cancel this x, and we have 6 equals 2 square root of 2x, and now I'm going to divide by 2 square root of 2 on both sides. And what do I get? I get x equals 2 goes in 6 3 times, so I have 3 over square root of 2, which is a very good answer, but usually we do not like a number in this format. We're going to rationalize, and we're going to get here the final answer. So I'm going to say here AB will be 3 square root of 2, and square root of 2 times square root of 2, that is just 2. Of course, if you need to evaluate, grab a calculator and do it. Okay, so you see in this problem we use the area of the similar figure to find first the scale factor part, first part, and then we use that scale factor for finding missing parts. In my next part of the lesson, we're going to look to similar solids which have the same shape but not necessarily the same size, and very similar. We have scale factor, which is a ratio of the corresponding sides. And in this case, you notice I have two ratio, the radii and the height. They have to be the same. One more thing here, all spheres are similar, all cubes are similar. All square are similar, you remember. All circle are similar also. Something that you may need in your math class. So now my first problem here is going to be to see if these two solids, these two cylinders are similar. So how are we going to do that? I will suggest you to start to large to small. I think it's easier. So 9 over 6. Do this ratio first. No need to write the units. It's the same unit. 9 over 6 is 3 over 2 if you simplify. And then also do the same for the other two pieces, the heights. 30 over 20 inches. And if we simplify, and here we can cut the 0 simply like that, we get 3 over 2. You notice it's the same number, so this is the scale factor. If the number is different, then these shapes are not similar. But since they are the same, the two shapes, the two cylinders are similar. Now we're going to use this property. You see, in this case, we know these boxes, these two rectangular prisms, are similar. Can we find the value of the missing, the dimension? Can we find A and B? So how are we going to do that? We're going to look first to these 24 and 8. Those are the corresponding parts. And again, if you remember, I like to start with large over small. It makes more sense to me. And some of you may see, hey, this is 3, this is the scale factor exactly. But you can leave it like that, especially if you cannot simplify. So 24 over 8, and now what? A over 6. And how do we find A here? Cross multiplication. 8A equals 24 times 6. We can divide by 8. And we have here what? We can simplify or grab a calculator if that's needed or allowed. Then we have 3 times 6, that is 18. Always when you get an answer in this type of problem, see if it makes sense. It does. This should be more than 6, and it's 3 times more, by the way. For the B, I'm going to use the same pattern, the same way. I'm going to have the same 24 over 8 equals now what? B over 9. So we're going to have 8B equals 24 times 9 divided by 8. So we have B equals, again, we can simplify here. 3 times 9 is 27. And again, is this a reasonable answer? The answer is yes. We can see it and we can move on. And now on this one I said, let's explore the relationship of the surface area and the volume of similar shape. So For the surface area of these two rectangular prisms, I'm gonna write here, and you can calculate if you want. Surface area of the large figure is 2 times 10 times 12, the two bases, right? The top and the bottom. But we have two more faces, left and right, right? 2 times 12 times 14. And we have two more faces. Yeah, we have front and back. This one, which is 10 by 14, front and back. So again, I'm going to say 2 times 10 times 14. And very similar, you can do the surface area, or even the lateral area, by the way. It's a little bit easier, of the small shape. That will be that. That will be what? 2 times 5 times 6. Plus 2 times 6 times 7 plus 2 times 5 times 7. So if you need to review the surface area, you can go on my YouTube channel and get how to do it. When you calculate these two, you will notice you get a ratio. After you calculate and you do the ratio, which is going to be the scale factor square. It's right here. Okay, so here I start to small to large, and that's the reason I have this 1/2, which is the scale factor. Yeah, if I'm looking, this is a reduction. I go from 10 to 5, 12 to 6, so that's the reason. But again, you see that r squared. But what is also very important, if you do the volume of the small or the large, let's start with the large, right? What will be that? 10 times 12 times 14, right? And the volume of the small prism, 5 times 6 times 7. We can use this shortcut for this rectangular prism. If you do this ratio, and again, like small over large, you get this 1/8, which is r cubed. So now that allows us to get these rules that are very useful. The first one, you notice, is about areas. So if you have a scale factor r, then the ratio of the area is r squared. Very important to remember. On the other hand, for the volume, if it has a scale factor of r, the ratio of the volume is r cubed. So that will be my last part of the lesson. We're going to use these rules for solving more math problem, obviously. And here I summarize this, how we call it, r squared, r cubed. Okay, so you notice these two packages, these two rectangular prism have a ratio of the areas of 25/36. What is that? That is r squared. 25/36. And this, you notice, is small to large. And let's keep it like that. How do I find r? Taking square root. And in this case, we have 5/6. So that is one thing you can find very fast. How can I find the ratio of the volume? You cube these guys if you need. And this will be 125/216. Sometimes you're going to need this, r cubed. So you see, you get one of them, you can get the other two. In this case, we have r squared. We're able to get r and then r cubed. Moreover, if I need to find the sides, I can use this r now and get each side. I can get this side, I can get this side, I can get this side, because they follow the same scale factor of r. I'm gonna do, let's say, this one. So now you need to be careful there, because you go from small 12 to a large. So I'm gonna flip that guy, because other than that I don't get what I need to get. So this one cannot be simplified, so I'm going to use a calculator. 12 times 6 divided by 5, so that will be 14.4. But then I can go and get this 4 and multiply by 6 over 5. And that will be, again, I'm going to use a calculator. And that is 4.8. And the last thing, we're going to do 10 times 6 over 5. This 5 goes in 10 two times, and 2 times 6 is 12. So you see, just by knowing these two packages are similar, we can do a lot of things. In my next example, we know that the surface area of the two similar figures are 480 and 1080 square inches. And we know also the volume of the larger figure is 810 cubic inches. We need to find the volume of the smaller figure. We don't really need to see the figures, okay? We just need to write the ratio. And my piece of advice, start always from large to small. I think it's easier. So in this case, we have this 1080 over 480. What is this ratio? This is r squared, because these are the areas. And if you do not remember that, you can see it here, square inches. Now try to simplify this, and this 0 is gone. 108 over 48. Can we simplify this? Of course, if you can use a calculator, that's even better. They are multiple of 2, or we can, yeah, 54 over 24. We can divide one more time by 2, and we get 27 over 8. I'm sorry, by 27 over 12, my fault, sorry. Okay, so we get this 27 over 12. We can simplify by 3 now, and we get 9 over 4. Okay, so by the way, that's probably the best way to do it. Even a calculator here might not be very helpful. And this is r squared. 9 over 4. How do I find r? Take square root. Okay, and that will be, oops, 9 over 4. And that will be 3 over 2. But of course, now we're looking, we need to find the volume. So for finding the volume, we need to cube this r. And 3 cube is 27, 2 cube is 8. Now, this is the ratio. I'm going to use it now for my last part of the problem. I'm going to make a ratio of the large over small, and we talk about the volume, and that will be r cube. So in this case, we have what? The volume of the large figure is 810 over volume of the small, that's what we need to find out, equals 27 over 8. Again, cross multiplication, we have 8 times 810 equals 27 times the volume of the small. Oops, let me rewrite that S. And how do I get now the volume? I divide by 27. So let me grab the calculator, and I'm gonna do it on the calculator. We can do it. We can simplify if you want. You can try that. Here we have 8 times 810 divide by 27, and that will be 240. 240 cubic inches is the volume of the small shape. And you notice we don't really need to see the shape. By using the scale factor, we can get everything we need. In my next example, we have two similar figures, two similar cylinders. We need to find the scale factor. So here we want to start with what is given here, the two volumes. Make a ratio, and I'll say go large over small. It's easier in my opinion. 432 pi, you don't really need to write the units since it's the same, over 250 pi. The first thing I notice, this pi is gone, which is good. Then I have this 432 over 250. And here I notice both of them are even number. I can divide by 2, and this one is going to be 216, and this 250 divided by 2, 125. Nothing else we can do here, if I am correct. Yeah, no. The question, and this is r cube, and I need to find r. So r cube is 216 over 125. How do I find r? I'm gonna take cubic root, how it's called. If you have a calculator, that will be useful. If you do not have a calculator, or you cannot use a calculator, think about what number times itself 3 times is 216, or what number times itself 3 times is 125. It's not that complicated. These are 6 and 5. So 6 times 6 times 6 is 216, and 5 times 5 times 5 it's 125. So r will be in fact 6 over 5. But a calculator will be very useful. And that's it in this case. So we can go from the ratio of the volume, and we get the scale factor r. And the operation is taking cubic root, or finding the number that raised to the third power is that r cube. In this last example, we have the volume of two similar cylinders, r 375, and I put here, which is a problem, it should be cubes, and 192 pi, and again it should be cube here. So again we have to find r cube here, and we have 375 pi over 192 pi. These 2 pi cancel out. It looks like both of them are divisible by 3, right? We have 375 over 192. So 375 divided by 3, that will be 125, which is a nice number, right? We just had it before. 192 divided by 3 is 64. Another nice number, right? Because now I can find r. R will be cubic root of 125 over 64. So you can use a calculator if you have. Or what number raised to the third power is 125? That will be 5. We just had it. One number raised to the third power is 64. That is 4. This is r, the scale factor. Okay, and now we can go and answer to the last part, we need to find the circumference of the base of the smaller cylinder, right? So by the way, here we have we start with the volume of the large over volume of the small. So this, we're going to use this guy. Circumference, ladies and gentlemen, circumference is nothing else than a length. So we're going to have to use this R. So the circumference of the large circle of the base of this cylinder over circumference of the base, which is a circle of the small, will be 5/4. And we know the large one, it's 25 pi. So we have here 25 pi over circumference of the small equals 5/4. We're going to do cross multiplication, and if I have 5 times the circumference of the small circle equals 4 times 25 pi, divide by 5 here, and the circumference of the small circle will be 5 goes in 25, 5 times will be 4 times 5, 20 pi. So that is the lesson that covers what we call R, R squared, R cubed. You know one of them, you can find the other two, and you can use these ratios to solve and find volume, surface area, circumferences you see here. If you enjoyed this lesson, don't forget to click the like button and come back on C Square for more help. Thank you.